Okay, today we're going to do a solution of Power Gaming. This was the final round of 16 knockout case in the AM session of the Excel World Championships. So we basically have a bunch of monsters here with various stats and our character at various levels having their various stats. And we're going to have these fight and determine who wins first. So I'm just actually going to put that under here to make it a little bit quicker to look stuff up because it's all the same data in the same order. Let's start with the bonuses first. What is the smallest number of sides a die can have so that the sum of its numbers is larger than 1,000? So to do sum of sequences, it's n times n plus 1 over 2. So you could just say equals, let n be 100, then do n times n plus 1 over 2. And then you could kind of do it by trial and error. So when you do 50, you're still too big. And so on and so on. So a little trick is if you have n times n plus 1 over 2 equals 1,000, you can sort of rearrange this equation. So if you were to multiply out the brackets, you get n squared plus n equals 2,000. So you'd rearrange that equation. So if you do square root of n, you're basically almost there. So you can do square root equals square root of 2,000. And that will give you an approximation, 44. So the answer is actually that rounded up, 45, like so. And then you could do the first test that I showed you to verify that 45 was indeed the correct answer. Okay, now for a dice that has 10 million sides, what's the sum of its numbers? So we can just do 10 million times 10 million and 1. So it's n times n plus 1 over 2. And then let's get into some questions. So the first question is basically summing sequences as we just did. So now that we know how to do that, we can say equals extract numbers. Let's pull my lambdas in, that would help. Extract numbers of this. So that's our n, so we can do that times that plus 1 over 2. Drag that down, and these should be our answers. And then exactly the same thing for the next question, except we have it a little bit more complex. So the number of sides on the dice is in the middle, and then we're going to plus 6 at the end, and we have 4 dices. I actually need to put allow decimals on this as well, because some of these have decimal numbers, like so. So we have a 2.5 at the end. My lambda for extracting numbers has a decimal and a non-decimal version. So I want the decimal version. So I'm going to say equals this times 1 plus this over 2. So that's the sum of the sequence, and then we need to divide it by the number of sides on the dice to get the average roll. So the average roll for this dice is 4.5. And another maths trick, you might notice I've multiplied by the dice and divided by the dice. So you can actually just take those two things off, and it's just 1 plus the dice number over 2. So we then want to times that whole thing by 4, because we're throwing 4 dices, and plus that 6 there. So this should be our answers here. And then we're going to use this a lot in the case. So I'm going to turn this into a lambda. Apparently there's a tip with Robot to put your headers here and it will automatically recognize them. So let's give that a go. So let's do input cells, generate lambda statement. Okay, it has given us dice, but it's dice underscore 2. So let's just call it. I already have a lambda called dice, so maybe that's why it does dice underscore 2. So let's do average roll. Then let's say OK, and let's save lambda as average roll. Accidentally, I labeled my input to the lambda wrong there, but whatever, I'll roll with it. So now we can do the next bonus, which was what is the sum of damage dealt by all 6 monsters. So we should be able to go equals average roll, it happens to be right at the bottom, which is annoying, of this dice. So I should just need the sum of all of those, which is 78. Okay, good. Then we're actually having our character fight a monster, and we're determining what the hit chance is. Now whenever I have a case like this where it's a battle, a bit like Clash on Titan, I generally prefer to do it with a model. So I'm contemplating right now whether I just do this single cell all the way down or with a model. I think I want to get into the habit of doing it with a model, because this case is going to lead us to like who wins and how many turns and how much health does the winner have at the end of the fight. Now you can do that by taking their starting health and then how many turns it takes to kill them, doing a calculation like that kind of in quite a single cell approach. But I wouldn't know that if I hadn't done this case before. So spilling out a model will solve it in a similar amount of time and allow me to know like on which turn their health went below a certain amount and so on and so on. So I think I'm going to try to do a model just to be in the habit of it. So let's get our hero stats out and enemy stats out. Let's get our average damage. So we can say XLOOKUP this in our table and get our damage roll. It's got merged headers, that's annoying. Let's unmerge that. I should really start using tables as well, so I don't have to keep flipping between these, but I'm in a bad habit of just doing it like this. Let's get the damage roll, and then actually if I lock those, then I can just pull this across to get the enemies, and then I can do average damage of that. What did I call it? Average roll, which I think is actually damage anyway. And this question is asking for hit chance, which is written here. That's how we calculate that. So let's just put that up here so I can remember what I'm doing. I think it's actually going to be easier to spill all of these things like this. So I might just do that. And then I am going to do equals our level, equals this. And then I'll do XLOOKUP this in here, give me all that stuff. And then I can gather all of the stats for each level. So let's do damage, let's do hit chance, let's just call it hit C. So damage is equal average roll of this. And then hit chance is going to be 21 minus defender's armor class. So if my hit chance is going to be defender's armor class plus attacker's hit attack bonus, which is here, over 20, so that should be the hit chance. And I should be able to just drag that down and move this to here. Okay, so the question here is asking for the hit chance of our attacker times 100. And I've just updated my Excel to the latest version. So data tables were working before, are they still working now? Looks like it, so hopefully those are the right answers. I did roll back to an old version so that data tables were stable. So we'll see what happens with this. Okay, now we're going to deal damage to the monster. So we want to know how much damage we do in 1,000 turns. And the damage per turn is the hit chance times the average damage per hit. So this should be quite easy. We just need to go to 61 now. Example 4. So I think this is literally just hit chance times damage times 1,000. Okay, that's nice and easy. Now we have a model. Okay, now the monster fights back and we want to know the health of the winner rounded to the nearest integer. So do I want to spill a full model here, or do I just want to do the HP divided by turns? So normally when I do a full model, I will do like turn, attacker, defender, and then I'll do kind of health before, health after, and then it's very easy to spill it down. But just because I know this case is simpler than that and doesn't require it all, I think I'm just going to do the HP over turns. Turns to kill, hero, monster. So the hero is going to die in his health points, which is this, divided by, I'm going to put it here, and I'm going to say equals this times this. This is going to be our damage per turn, and we're going to round that up. Round up. So it's going to take 10 hits to kill the hero, and then for the monster, it's going to be the monster's health divided by our attacker's hit chance rounded up. So it's going to take 43 turns to kill the monster. So then let's say wins. I'm actually going to call this dies in because it's a bit confusing having so hero dies in 10 turns. So then let's do equals if the hero dies in less turns than the monster, then the monster wins, otherwise the hero wins. I think that's the way around I want it, so the monster wins here. So I can say if the monster wins, it means he survives and he's taken this many turns of hits. So it's going to be the health of the monster minus this times the damage. So it should be that. So is our answer 76-ish? No, it's 45. Oh, because we're on example 5. Yeah, so it's 45. Okay, so if the monster doesn't win and the hero wins, it's actually going to be our health points minus the monster's turns. But if the hero wins, the monster doesn't get to hit back. So it's going to be the monster turns minus 1. So it's going to be that minus 1 times that. That's always the confusing thing about these, where hero goes first. Like if the monster wins, it's 1 less turn when you're doing the health calculation this way. But anyway, that should be this, and I can round that with robots, and we want to go from 81. Has our data table updated? I don't know. We'll see. Okay, good. No, we got one wrong, so question 98. I can see the problem, so the hit chance is above 1 there. So I need to cap this hit chance between 1 and 0. So I can say median 1, 0, that. Okay, that would have caught me out in the real thing. I need a bracket. There we go. Median 1, 0, and then all that stuff. And now we get the right answers. Okay, that would have cost me. Okay, level 6, we have multiple actions per turn. Each of them basically get 3 actions, but there's a penalty to their hit chance of 5 on the second go and 10 on the third go. So, example 6, I can see how this case is actually really quick with this data table method. I imagine this is how Andrew did it so quickly and got full points on the day. So this is going to be 101, and now we're going to have new damage calculations. So let's do, so let's just copy these out here and here. And our new damage calculations, so actually, and we can do it here, and we can do this one here. So the first hit is going to be the same. The second hit is going to be this, and we're going to get a minus 5 in the middle here. So let's just do that to both of them. And then on the third hit, we're going to get a minus 10. Minus 10. Let's actually remove the old damage because I don't need it now, I don't think. So now I can say equals damage times these. So this is our hit chances. And I can sum that up. And that will give us the new damage. So then this, the ref can be, this is the hero dying in, this is the hero dying, so it's going to be that cell. And then the monster dying is going to be taking damage from the hero. There we go. And then this is going to be, if the monster wins, it's going to be the monster's health minus the turns of the player's damage. Otherwise, it's going to be the monster's turns minus the hero's damage. So hopefully that's right. What do we get? 53 looks good. 1, is that correct for the answer? Yeah, I guess so. Okay, level 7, we have a tripping bonus. So for the first go only, we adjust the hit chance again by doing a +2. Actually, we do a +2 to everything, and he does the first hit twice, and then the monster only gets 2 hits. Okay, so the monster is actually only going to get 2 hits on his first go, and then it's going to be normal. So let's actually do 2 calculations. Normal, and then let's do first turn. Okay, so the monster is going to be easy. It's going to be the same thing again. So it's going to be the damage times the chances, but only for 2 turns. And then the hero is going to get 4 turns. So we're going to have this tripping bonus thing in there. So I think I'm just going to redo this formula. So that's our first chances. So let's just H stack our chances together. So it's this plus 2 inside for the tripping bonus, and then I think I want to just copy that 4 times because he gets 4 hits. And so on the next hit they have the minus 10 penalty, sorry, it's minus 5, and then the next hit they have a minus 10 penalty, minus 10, and on the next hit they don't have any penalty again. Do they keep the tripping bonus? Let's assume so. Do they keep the tripping bonus on the 4th? Blah, 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 blah. Yeah, looks like they keep the tripping bonus. So I just need to times all that stuff by the damage and sum it together. So that is the first turn only. So now let's just do HP after first turn. So it's going to equal the health points minus the monster's first hit, and this is going to equal the monster's health points minus the player's first turn. And I should just be able to change the health points to be this cell instead, like that. Hopefully that's the answer, and then we go example 7, 121, and should be 46. Because I need to move these health over as well. So let's do that. There we go, 46. That seems a bit too easy to be true. Oh, it is 121. I do that a lot on my data tables, like put the question number too far. We get 2 wrong. So 123. It's because the monster's already dead after after 1 hit. So I think we are just, we're one-shotting this goblin here. I didn't amend for that in my model, so the answer is just going to be 40. I shouldn't really do these manually, but I'm going to. And then this question, wait, which number is it? 124. Again, we one-shot a monster, so it's going to be 48. That's a sneaky couple of questions there, but I mean, you need to model it in case that happens. Anyway, that's that. Now let's use this model to do the final 2 bonus questions. So characters on level 20 fights all monsters from the list 1 by 1. His HP does not restore. What is the remaining HP of the monster that beats him? Okay, so let's copy these as values. We're at level 20. We'll start with the first monster. And then we're just gonna do a data table for all the monsters basically. That's going to be the easiest way to do it. And let's delete this out, delete this out. So I do actually need to fix these whole dying on the first turn things now. So I'm going to say if error, then the hero dies in, let's say 1,000 turns, i.e. they don't die. And now we're getting the hero's health out. And the monster dies in 1 turn. But anyway, I think we'll roll with that, and then if we just do a data table here on the monsters, so basically this is how much health the hero has at the end. So he kills that in 1 hit, he kills that in 1 hit. Orc Filter he kills in, 1 hit. XLOOKUP Troll, it looks like he doesn't kill it in 1 hit. So the hero actually has 173.75 health left. So I'm just going to cheat and brute force this. So I'm going to copy those as values, and I'm going to put his health after that monster in there. So we've just fought XLOOKUP Troll, so now we're on this dragon guy. So now he has 142 health, so let's force that into there again. And then on Pit Error, we should see Pit Error win this one, I imagine. So the monster wins, and he has 47 health rounded. So we have the tripping bonus on at the minute, so that's the last question. So 47. Then we need to do the same thing again, but without the tripping bonus. So HP after first turn, let's just minus off the normal damage. And then we just should be good to do the same thing again. So we started at 176 HP. So let's put that back into our model, 176. So again, it's XLOOKUP Troll that damages us first. And we have this left, so let's put that into here. And then Dragon Array takes us down to 141.35. And then Pit Error should win with 84. So let's try 84. There we go. Okay, so that was a very manual approach at the end. I didn't really like the method I did here actually, but it works for something this small. I guess if it was a bigger model, I'd try to do some sort of lambdify on who wins and how much health there is, and then iterate through it somehow. But anyway, this works. I think this is probably the way it went for Andrew in the real thing, because he got like 100% of this case and he was the only one to do it. I mean, he did it really fast. I think he normally takes more of an approach similar to how my natural way to do things would be, and that's to kind of spill things out into some sort of model and just run it like that. It's actually, although it's fairly manual, it's quite quick rather than doing a general solution that would solve for any number of enemies and everything else. So I think I only have 2 more cases to do now. It's a crab and daggers, and I think I've uploaded solutions to all of them. So now I'll have caught up and I can do some other stuff, which would be good. All right, see you next time.